Hello friends, so this is my day 2 for problem of the day from GFG. So let's see the problem for today. So this is our problem, it's about tree. So given a binary tree, count the number of single valued subtrees. A single value subtree is one in which all the nodes have same value, right? So this is a tree given, you can see in the example. So let's take that example and see what the question is saying, right? So this is our question, right? Okay. So what does it say? So this is a tree. Okay. This is a tree which is given, and we have to count the we have to count single value subtree, right? We have to count the single value subtree. Okay, uh, so first understand the what are the subtrees of this tree. Okay, so you have to count single valued subtrees. So first understand what are subtrees of this tree. Okay, so this is in total a tree. It has subtrees which are this node, right? This node is itself a subtree. So this node is a subtree. This node is a subtree. This subtree 155, this is a subtree. Okay, 155. Okay, then this is a subtree, this is a subtree, and this total is a subtree, right? So it has 1 2 3 4 5 6. So it has 6 subtrees, right? 6 subtrees. So we have to count the number of subtrees which has a property called single valued subtree, right? So what does that mean, single valued subtree? A single valued subtree, listen to my words carefully. A single valued subtree is a subtree, so it must be a subtree. Okay, and a property that all its nodes are equal value, all its nodes are of equal value, right? So see these subtrees, I'm just writing all the subtrees cleanly. So 5 5, this one again 5, this one, and right. So see this subtree which has only one node, so there is nothing to compare, right? So it is already a single valued subtree. This is a single valued subtree, right? So we can make a conclusion that all the leaf nodes, right? So I will tell you that later. So for now, this is a single valued subtree. So similarly, this is a single valued subtree, right? So I am marking the single valued subtree as in red color. But this is not a single valued subtree, right? So this is a tree, subtree is a tree. So this is a subtree of this tree, but we are now considering this tree. So this tree has all nodes. Is in this tree, are all the nodes are equal? No, because this and this are equal, but this is not equal, right? So this node is not equal with this and this. So if it was 5, then we can say this is single valued subtree, but this is 1, so value is not equal. So all nodes value must be equal. So this is not a subtree, right? So just erasing this one. Okay. Is this a single node subtree? Obviously, single node subtree, right? Is this a subtree? A single value, right? It has two nodes in total, 5, 5. Two values are equal. So all the values of the nodes are equal. So this is a single node subtree. Is this a single node subtree? No. We can see 1 and 5 not equal, right? So if it was 5, then in total the all the values of the nodes are equal. But this is not right because it's 1. So this is not a single node subtree, right? So this is not a single node subtree. So what are the results? So the results are 5, 5, again 5 and 5, 5, right? So you can see the answer is 4. So you have to count the number of single node subtrees. So the answer is here is 4, right? So you can see that their answer is 4. Okay. Let's take another example. Then we will go to the solution part. So I will first tell you about what we are gonna do. Then I will code. Then I will again tell you with the code that how the code is running. Okay. So I will try run the code. So first we will just take an example. So forget about the this example. I'm taking a new example. Suppose this one. So we are just considering few examples. One is this one. Let me draw a line. So this is line. This is for one example. This is for another example. This is for another example. This is for another example. I don't know how many examples I'm gonna do. So I'm just drawing the lines. So take this example. 9, 8, 7, 8, 8, 7, 7. Okay. Then I'm going to do 0, 1, 2, 3, 4, 5, 6. Then I'm going to do 9, 8, 7, then 8, 8, 4, 3, 7, 7. Then 9, 7, 7, 7, 1, 2, 8, 8. So for now I'm just taking this much examples. Okay. So let me erase these parts. And yeah. So this just let me minimize these things. This is my example. This is my another example. Okay. This is my another example. This is my another example. Okay. So let's see. Right. So till now what we know exactly for obvious the sure answers, the answer we can see after seeing the tree. Okay, so immediately we can see the answer and till that answers. So sure answers, we don't have to need any calculation, we don't have to do any calculation for that. So what are the sure answers? The sure answers are only the leaf nodes, right? You understand? Leaf nodes. Why? Because all the leaf nodes are have only one node, so nothing to compare. So it is already a single value subtree, right? Okay. So what are the leaf nodes? I hope you know the leaf nodes. The leaf nodes are the nodes which has its two subnodes as null. Okay. So this has two subnodes, left node and right node, which are null. This 8 has two left and right node as null. Similarly, this for this case, this. Okay. So in this case, so suppose I gave you this one 9875. So is this a leaf node? No, its left one is null, it's right, but right one is not null. You have to be sure that its two nodes left and right should be null. Okay, so I hope you know leaf node. So these are leaf node, this is a leaf node, this for this case, this for this case, this. Okay, so these are the leaf nodes. So all the leaf nodes are a single subtree. I mean this when you consider the leaf node as a tree, a subtree. Okay. So this is my sure answer. So I am going to write the sure answers first. The sure answer. Okay. So these are 8, 8, 7, 7. In this case, the sure answers are 3, 4, 5, 6. 4, 3, 8, 7, 7. 8, 8, 1, 2, 7. Okay. So these are the sure answers, right? So see this. So here 8 is a single value subtree, right? So 8 is a single value subtree. This 8 is a single value subtree, right? So we got two single value subtree from here. Now look at this subtree 8. Look at this subtree 8, 8, 8. This is a subtree, a single value subtree. This is a single value subtree. That means that including 8, all its subtrees, have same value. For this one, including 8, all its subtrees are same value, right? So these two subtrees have all its nodes as same value, right? So what the property we need to tell that this is a single node subtree? Listen to my words carefully. So what we need to see that this is a single node subtree? So we need that the left subtree must be a single node subtree. The right subtree must be a single node subtree, right? So if the left one is not a single node subtree and you are saying this tree is a single node subtree, it doesn't mean anything, right? So the by saying that this is a single node subtree, we mean that this value is equal to this value and all other subtree values. Okay, so you are saying that this is not a single node subtree, this is a single node subtree, so this is not a single node subtree, this is a single node subtree, and you are saying this is in total is a single. So this doesn't mean anything, because it has to be a single node subtree to be a single node subtree for that this tree. Okay, so all I want to tell you is that this tree 888 will be a single node subtree if its left subtree is a single node subtree, its right subtree is a single node subtree, and the value of this root node for this tree, this is the root node, right? Root node is the topmost node from which all the branches are coming. Okay, so this 8 root nodes value, its value, so value of these roots must be equal to its left value and also its right value. It must be equal to all these values, because then we got that this value is actually has all the nodes as same value, and sorry, this tree has all its values as same value as this, and this tree has all its values, subtree values, same as this, and this value equal to this value, and this value equal to this value. So all the three values are equal. So this is obviously subtree, because this is a same value as this and this, and these values are equal to all its subtrees, and this value is this this subtree, this value is equal to all its subtree values, right? So suppose what I am trying to say is that, suppose this is the case, 8 8 8 8 8 8 8, okay. So you are considering this total tree, is this a subtree, a single value subtree or not? So you are just considering, you are just caring about that, is this is a single value subtree. So what I told you, that for this whole tree to be a single value subtree, you need to see, is you need to check that its left subtree is a single value subtree and its right subtree is a single value subtree, okay, right? So if its left subtree is a single value subtree, then this value is equal to all the values of in this subtree, right? So you don't have to care about all other values if you can assure me that this is a single value subtree. Similarly, in this case, if this right subtree is a single value subtree, then this value must be equal to all other values in the subtree, right? So you are just saying me that I have give you this tree with together with that this is a single value subtree, this is a single value subtree. So I will only check, you gave me a tree together with that this is a single value subtree, this is a single value subtree. I will only check that this value equal to this and this value equal to this. So if these two values equal and these two values equal, so obviously this 8 is equal to this 8, and as this is a left single value subtree, this value is equal to all its subtree values, and this value is equal to all its subtree values. So this will be equal to all its two subtree values, right? All its subtree values, right? So I need to check only that this value is equal to this value, this value is equal to this value. So root value of root must be equal to left value, and value of root must be equal to right value. I hope you understood that. So then I can say that my this total tree, this tree is a single valued subtree, right? So I hope you understand. So let's take an example where this case, so to check. Suppose this is the case, 8 8 8 7 7 6 6, okay. So you gave me this tree and you have told me that this is not a single valued subtree. Why? Because you can see that 8 is not equal to 7 and 7. Here 8 is not equal to 6 and 6. You gave me that this is not a single valued subtree, and this is also not a single valued subtree. So I will check, I will not check here that is this value equal to this or not, because this is not a single valued subtree and this is not a single valued subtree. So the values of here and in its subtrees, the values of here and in its subtrees are not equal, right? So the values of here, if it is already equal to, if it is already equal to this 8 or this 8, that doesn't actually matter now, because it will not be equal to all other values in here, because this is not single value subtree, this is not a single value subtree. So this value will not be equal to all the values in here, right? So this will never be a single value subtree. So this is a condition, necessary condition, right? So what we got? We got to be that if this to be a single valued subtree, this must be single root subtree and this must be single root subtree together with this value equal to this value and this value equal to this value, right? So let me check. So I got already that this is a subtree, a single root subtree, this is a single root subtree, as these are leaf nodes, and I see that this value is equal. So yeah, obviously this is a single root subtree, right? Now check this. This we are already checked. 7 7 we are already checked as these are leaf nodes. So let's check this subtree. 7 7 7. So we can see that this is a single value subtree, this is a single value subtree, and the values with this and this are equal. So this is a single value subtree, right? And in total, I got this is a single value subtree, right? This is a single value subtree. That's right. So I am checking if left one is a single value subtree, right one is single value subtree, and the value also with its left and right nodes must be equal. But in this case, 9 is not equal to 8 and 9 is not equal to 7, right? So this condition fail. So this is not this whole tree is not a single value subtree, right? So our answer is 1 2 3 4 5 6. So let's do this. So 3 4 5 6 we got already. So 1 3 4. So this is not a single value subtree, this is not a single value subtree, and obviously these two are not a single value subtree. This whole will never be a single value subtree. So let's check this one. Similarly, this is not a single value subtree, and similarly the whole is not a single value subtree. So the answer here is 4. Here the answer was 1 2 3 4 5 6. For here 4 3, like, so we are checking 8 4 3. So is 8 4 3 single value subtree? So 8 is not equal to 4, 8 is not equal to 3, no. So this is not a single value subtree, this is a single value subtree, right? But to be a single value subtree for this whole tree, both of these must be single value subtree. So this is not a single value subtree. Is this a single value subtree? Yes. These two are equal single value subtrees, and this is equal to this is equal to this. So this is a single value subtree. So we got a single value subtree, right? In this case, this is a single value subtree, this is same, right? So this is same because 8 is equal to 8, 8 is equal to 8. So 8 8 8 is a single value subtree. Here 7 1 2 is not a single value subtree, as this is not a single value subtree. So whatever this is yes or not, we doesn't really care about that, because it will never be a single value subtree. So 7 7 7 1 2 is not a single value subtree. So as this is not a single value subtree, this is a single value subtree, but this is not a single value subtree, right? So it will never be a single value subtree. So the answer is 1 2 3 4 5. Okay, so I hope you understood that. So let's code first. So what our actual goal is, suppose taking this one, 8 8 7 6 5 5. So what we are going to do is we are going to traverse, okay, we are going to traverse the tree like this, and if we got a leaf node, we will return the count. We will use a count variable which will give me the answer for the number of single value subtrees. We will return the count as 1 because leaf node is a single value subtree. So we will go in the post order. So I got a leaf node, I will return 1. Then again I got here, I will return 1. So I will check here the value is equal or not. This is equal to this or this is equal to this or not. I will take another variable. I will return another variable together with this count for this subtree, which is true or false for is this a subtree or single value subtree or not. So this is a single value subtree. So this will return true and count and is data 7. So all the trees and nodes are actually returning. So we will see that later. All the nodes are returning actually 3 things. Okay, one is its value, second is its count, that is if suppose for this one what will this return to its ancestors. It will return its value, the count of single value subtrees under this, that so what it means, because that if there is any number of single value subtree under this subtree, suppose this is a single value subtree, this is a single value subtree, so it will return 2. If this was 5, it will return 3. Okay, so what will the node return? I am again telling you, it will return the number of single value subtrees under this subtree. Okay, so here the case is 2, so it will return 2. And what will return? That if it is a single value subtree, it will return true, otherwise false. Okay, so in this case it will return 7, count as 1 and true. It will return 6, it is a single value subtree, so 1 will be returned, and it is single value subtree, so it will return true. So we see that the left one, as why we are doing these things, why we are returning 3 things, right? So because the conditions are that, say, left subtree must be a single value subtree, right subtree must be a single value subtree, and the values must be equal, right? Values must be equal. So we have to check these values, and also if this is a subtree or not, single value subtree or not, and the count also, because I have to return the count here, it will return the count there, right? So this is the reason. So see, okay, so I am just cleaning these things, doing this in a fresh manner. So 8, 8, 8, 7, 7, 8, 6. Okay, so it will traverse like this. It will return 7, count as 1 and true. Then it will go like this, it will return 7, count as 1 and true. So for this node we got 7, 1 true from left, and from right we got 7, 1 true, right? So what will this one return to this? What will this node return to this? Its ancestors. That is we are going to see. So see, as this is true and this is true, so 2 subtrees are single value subtrees, right? So this condition passed. Okay, now we have to check this condition. So 7 is equal to 7, right? So we will actually calculate its count value. Every node has its count value. So for this one we will return 8 as its root value. We will return 8 as its node value, and count as left's count, right's count plus 1, because see, 7 is a single value subtree, so it will return all its single value subtree count. Similarly, this will return all its right single value subtree count, right? So this one has this much single value subtree count and this much single value subtree count. I mean, and if 8 is equal to, suppose these two are 8, okay, so if the case were like this, and if these 3 are equal, then it will return how many single value subtree counts? Count for this plus count for this plus in whole this is a single value subtree now, right? Because 3 conditions are passed. So it will return actually this count plus 1. Okay, but in this case the values are not equal, so it will return 8. It will return count as it will not add 1, because this is in total is not a single value subtree. So it will return only this count plus this count. This is 1 plus 1, 2, and false, because this in total is not a single value subtree. The tree becomes like this. It will return 8, 1 true. It will return 8, 1 true. Then here from left we got 8, 1 true, and from right we got 8, 1 true. So as both are true, right, and the values are also equal, so this one will return 8 as its value. 8 is its value only, okay, and count of 1 plus 1 plus 1 as, okay, this was 6, right? So the value is not equal actually, this was 6, So in this case it will return 8, count is 1 plus 1 2, and false as this is not single value subtree. And at last from left we got this, from right we got this, so as both of false, so it will never be a single value subtree, right, in total. So it will return 8 and 4 and false, and we'll print the result 4. Actually the answer is 4 in this case. Now suppose this was 8, so what we have to do, this was 8, so it will return 8 1 true, right? In previous case why I am writing this 8, it will be 6, right? It will be 6. Okay, so now suppose this is 8, so it will return 8 1 true, right? So from left we got 8 1 true, from right we got 8 1 true. So 8 is equal value, 8 is equal to 8, 8 is equal to 8, and 1 plus 1 2 plus 1, because this is total is a single value subtree. So 8 3 and true, it will return 8 3 and 2, right? So this is a single value subtree, but this is not, so in total it will never be a single value subtree. So the answer will be 8 and 2 plus 3 5 and false. So we will print 5 here. Okay, just clean this thing. So let's see this example. Okay, so we'll traverse like this. We will return 8 1 true here, we will return 8 1 true here, so we will return from here. Now calculate, we will return 8 1 plus 1 plus for this 2, for this 1, so 1 for left 1 for right, as in total it's a single value subtree, so plus 1, so 3 and 2, as it's as for this subtree. Okay, as 8 is its root node, so this total subtree is a single value subtree, right? So that is why we are returning 8. If this is false but this is true, or this is true, or both of them true, that doesn't matter, then we will return actually false. If this total subtree is a single value subtree, then we will return true from here only. Okay, from here to here. So from, we will traverse like this, 9 1 true, 9 1 true, we will return 9 to 3 and true, and we got 8 3 true from left and 9 3 2 from right, but this value is 8, which is equal to 8, but this is not equal to this, right? This value is equal to this but not equal to this, so this will not be a single value subtree. So we will return 8 as its root value, and 3 plus 3 6, and false, as this is not a single value subtree. So we will print 6 as my answer. So let's code now. So what we will do here is we will create a class. Okay, we will create a class first. Okay, so we will create a class called let's call it SubTree. Okay, and it will take values of the roots data, count till its node, right? So what I am telling is that each node here, suppose here, it will return its data, count till its, how many single value subtrees are there in this tree. Okay, so maybe in this tree is not a single value subtree. It may be possible that this tree is not a single value subtree, but these two are single value subtrees, right? So actually this will return 2. You may say that this is not a single subtree. So no, I am not returning as what I am returning is under this the count of single word subtrees. So this is 2, and a boolean value true or false, saying that if this tree, only this subtree or tree is a single word subtree or not. So that I am returning. Okay. So here will be boolean value which is called flag. Okay, and I am just creating a constructor for just initializing my value, and empty constructor and a parameterized constructor, data, and this dot data count and flag. Okay, so we are done. So now what we'll create a function for ourselves which will return subtree objects but accept node objects, right? Because we have to utilize this class thing, right? So we can't use this function as this is returning only int value and accepting only no node value. So there is nothing of this subtree concept. So we'll create a function called solve which will actually solve our problem and return us the three things. Actually solve root is returning an object containing three things. One is the root node value, which is 5 here in this example 1, and the count of single word subtrees under this tree. So how many single word subtrees are there in this tree? And the third thing is this in total is a single word subtree or not? Okay, so this will give me a bunch of things, 3 things: data, count, and flag. So we will only looking for count. So we'll return count. So we'll return this. Okay, so now let's create this function, public subtree solve root. Okay, so first things first, what was our sure answer? It was a leaf node. So what is the leaf node condition? Leaf node condition is root dot left must be null and root dot right must be null. So in that case we will create an object called base result. So this is our best result or best subtree, base no, this is actually leaf node subtree. Okay, leaf node subtree. So it's what it will return. So suppose this leaf node, what will it return? It will return its value. So root dot data, its count, which is 1 because leaf node is a single word subtree, and a flag which is true as this is a single word subtree, right? And I will return leaf node subtree. Okay, done. Now I will expect. So I am using recursion here. So I hope you know recursion. So I expect. So I am keeping faith that I am keeping faith on the function solve, that when I will call solve root dot left, it will give me when I will call solve root dot left, that is this subtree. For this node I am calling this part, this left part. So I am keeping faith that this function will give me the number of actually the left root node. It will give me the left root node. It will give me number of single root subtrees in this subtree, and is this subtree, left subtree is single node subtree or not. Okay, so I am keeping faith that this function will return me obviously these three things. So this is possible if, okay, so and also I am keeping faith that it will give me the same thing for right subtree. So what I am gonna do is I am gonna just okay, so let's keep that separate. Okay, and it may be possible that our left node is null, so I will call this function if my root dot left not equal to null and root dot right not equal to null, right? So I will call these two functions when this will happen. It may happen that roots left is non-null. Okay, so it may be possible, suppose in this case 5 5, 5's left one is null, right is non-null. So this is the case where I am calling the functions, two functions for left and right when both nodes are non-null. So if only the left one is non-null, only the left one is non-null, so I will do something else. And if only right one is non-null, I will do something else. So what we will do, I will only call the left part. This is obvious, right? I will only call the left part because right one is null. I am calling. Okay, so now what I have to do? Now I got the results, right? I am keeping faith. I got the results from left subtree and right subtree. Now I have to give my result, right? So I got the result. Suppose for this one, I got the result from my children's. Now I have to give my answer to my ancestors also, right? Because without that, this cannot compute its result, its own result. So I am saying once again, I got my children's results, but I have to also give my results because my ancestors need my result to compute his or her result, right? So I am going to create a my tree object here, which I will return at last as my result. So what the function actually returns, it takes a note values and returns subtree objects. So subtree root dot data. I am initially keeping the count as 0 and this is false. Okay, it may be true or false. I am initializing this as false. Okay, now what I have to do is I have to check that. So what was the condition? The condition that the left subtree must be a single node subtree and right subtree must be a single node right subtree. So if it's both are single node subtree, so this was the condition for me to be a single node subtree. For this one, this will be a single node subtree, or this one, right? So this one will be single node subtree if this and these are single node subtrees and my value is equal to this one values and this one values. So these are three conditions. My left one is a single node subtree, my right one is a single node subtree, and my value is equal to both the values of the children. So if lst.flag will give me the boolean value that is subtree on single node subtree or not. So these two are true. Okay. If these two are true, Then I have to check one thing also, the values. I have checked that, check this one. I have checked that my left one is single value subtree or not, right one is single value subtree or not. If these two are true, then we are checking the third one. If this is true, then I will say that this is, I got my single value subtree. I am a single value subtree. I will return my answer as true, right? So root dot data equal to left subtree data and root data equal to right subtree dot data. Then I will compute my count as left subtree count plus right subtree count plus 1, because I am now a single value subtree and my flag will be true because I am now a single value subtree. I will return my tree. Else I will count my tree as only the left subtree count and right subtree count. And I will return my tree. See, what I am telling is these are three conditions to be a single value subtree for me, right? So if both of the threes are true, I am giving my result as true. But if I got my result as false, some of the three or all of the three are wrong or false, then I am not a single value subtree. In this case, I am not a single value subtree, but I have some subtrees which are single value subtree. This and this, right? So I can't give my count as 0 because I have two subtrees, this one and this one, which are single value subtree. So I have to give the count as 2, which are this one plus this one. I am calculating the case of being subtree for myself by adding 1 to the left subtree plus right subtree result. Okay. So the answer is this one. 5, this 5, 1 gives 1, this 5 gives 1. So 2 is result. But if I am a single value subtree, I will give 2 plus 1. Otherwise, I will give only 2 because I have 2 single value subtrees. Give them. I will give it to my ancestor. But if I am not a single value subtree, my children are single value subtree, I will give their sum 2. Okay. So I hope you understood. So what I was doing, yeah. So in this case, I will compare only with my left one because there is no right. So if this is true, okay, then I will check root dot data with my left subtree dot data, and if it is true, then my count will be left subtree count plus 1 and my flag will be true, and I will return my tree. Else I will just give my count as my children's count and return my tree. For this case also, if my value is equal to the right subtree's value, then I update my count as right subtree count plus 1 and my flag will be true then. I'm returning my tree. Okay, so I'm missing one case. I have to check it is a subtree or not. else I will just calculate my count as write subtrees count, right, and I will just return my tree. So this is the case. If all the conditions failed, I will just return my tree. I hope it's done. If there is another case, no cases allowed left. I hope all the cases are calculated. So let's give it a run. Count is true. Why I gave it? Count is true. Oh, sorry. Flag. Oh, flag, flag, flag. Again showing me error. Oh, okay, so this is flag. This is also flag. Right. Why is giving me 0? Okay, so I was giving that part in this part, so it will be outside this part. So it will be outside this part, right? This was our mistake. So I think it will be okay now. I think it will be okay now. Right. Okay, fine. So we're compiling this. Yeah, it's run well. Okay, so we got it with 100% accuracy. Right. Fine. Let's uh, let's let's take this screenshot. Okay. So let's this screenshot. Okay. Let's take this one and delete this. So I will do the calculation for this example. Okay, with this example. Okay. No, this example. And let's calculate the result with our code. How it's calculating actually. Okay. So this is our question. 5, 4, 5, 4, 4, 5. Okay. So at first it comes with the solve. It comes in the solve function, right? So here this is pre-order. So I'm going like this is in order. When I'm going in the right side of this is post order, right? So I hope you know the order tree. If you don't know, check it on the YouTube. It has been there, very well explanations. So our left node is not null, right? So here our left is not null, right is also not null, not null, not null. So what we will do, we will call the uh, for left. For left the call is on, and again we reach here, and here also the two children are non-null. So again the left call is on, but here we got our base condition which was here, that both the children are null. So what we will do, we will create an object and return with object, and return in the object what things, root data 1 and 2, right? So then we come back with this call. We have done with the left call, we will do now the right call. The right call again, both the children are null, so we will return root data 1 true. So we are done with this part for this node. Okay, now both the flags are true, right? So we check for this value equal to this value and this value equal to this value, these are true. So we will return some, this data is 4, right? So we have assigned the data already in my tree. And my count, this count is will be now first left subtree count plus right subtree count plus 1, right? So 1 plus 1 plus 1, so 3, and we'll give my flag as true, and we'll return this, right? We will return this, so it will return this one. Now the tree goes like this, this. So why so let me see, let me show you the code tree. Like the tree goes like this, and get a null here. Here is a null for this node, here is a null, right? So this call will be on, root dot night not equal to null, root dot left is here is null, so this call is run, this call is run. So we go like this, and again we got a leaf node, so it will return 5 1 true. From here we got 5 1 true, right? From this call we got 5 1 true, and we check that it is true, right? So this is true, right? So it goes under this one, this data is equal to this data, so my count will be now 1 plus 1. So it, what will it return? 5. My count will be this count plus 1, that is 2. My flag will be true, and it will return this. So from left I got 4 3 true, and right 5 true true. So here is the call, here was the call. So I got, I was here for this node, so I'm here for this node, right? So now from left we got true, right? We got true, right? So we'll check the values are equal, right? So if this value is equal to this value is equal to this, so this value is not equal to this, right? So this condition fails. So we will do this line, we will execute this line. So my count will be first count, left subtree count plus right subtree count, right? So it will be 5, and I will assign right. So my data is 5, I will return my count as 5, and I will I have initialized the boolean value as false. So if I got, then my tree is a single node subtree, then this line will be executed and it will be true. But in this case this line is executed instead of this, so my tree is not a single node subtree, so I will return false here because it was false initially, it will not change. So this function solve actually return us 5 5 false. So I was returning count there, right? I was returning count there, so count is the middle value, so the answer will be 5. So let's check the answer here. The answer was 5, right? So the answer was 5. So that's it. So see you in the next video.